Let's divide two whole numbers, but with a rule. No multiplication, no division, no remainder operator. Only addition, subtraction, and bit shifts. Take 22 divided by 3. The answer, rounded towards 0, is 7. How do we get there using only shifting? Slow division would subtract the divisor one time at a time, which is far too many steps. Instead, we subtract in big chunks. Shifting a number left by 1 doubles it, so from the divisor we can cheaply make 2 of it, 4 of it, 8 of it, and so on. At each round, we find the largest double divisor that still fits inside what remains, subtract it, and add that many copies to the quotient. Then we repeat with the smaller leftover. Because each chunk can be huge, we finish in very few steps. We also track the signs up front and work with absolute values, restoring the sign at the end. First, we note whether the answer should be negative, then work with the absolute values. In the outer loop, while the divisor still fits, we double it, shifting left, as far as it will go without overshooting, doubling the count alongside. We subtract that chunk and add its count to the quotient. At the end, we put the sign back. Let's divide a few pairs, including a negative one. Record whether the result is negative, then work with absolute values and a quotient of 0. While the divisor fits, double it by shifting left as far as possible without passing what remains, doubling the count too. Subtract that big chunk and add its many copies to the quotient. Finally, restore the sign we saved at the start. Now, let's test it and hit run. (22/3 is 7, 100/10 is 10, negative 15 over 4 rounds towards 0 to negative 3, and 7/7 is 1, all without a single division. The shape is this. Save the sign and take absolute values. While the divisor still fits in what remains, double it as far as it will go, subtract that chunk, and add its count to the quotient. When nothing fits anymore, apply the sign and return. Because each chunk can be as large as roughly half the remaining value, the leftover shrinks fast. So we finish in about log n steps instead of n. We keep only a few numbers, so the space is constant. A few cautions. Decide the sign before you strip it, then divide the magnitudes. The result rounds towards 0, so 15/4 is 3, not 4. And in languages with fixed width integers, guard the largest value so the doubling does not overflow.